Hi, this is Kevin. Welcome to my tutorial on the Zelle book, Chapter 7. And this is a tutorial I'm associating with exercise 11. And when you read exercise 11, it has to do with figuring out which of a year that is input is a leap year. And this is just a complex decision, okay? The kind of thing you can't make happen with just one decision construct, and you have to combine them. And in this case, and in the tutorial that I'm doing, it's going to be a combination of an if, else with nested inside it some amount of if else's. Okay, and this is a pretty typical computing use case. This is where you deliver a lot of value. You can do well by taking your time to set up the problem well. Okay. In the Zelle textbook, they show you flowcharting for the problem that they do during the chapter, programmer flowcharting. And I don't really teach programmer flowcharting anymore. I probably haven't taught it in 30 years, and that's because programmer flowcharts allow you to diagram things that are really not good coding practices, and thankfully are not easily implemented in modern programming languages which enforce good coding practices. The coding practices I'm talking about are kind of come under the heading of structured programming. Okay. On the other hand, we do have a scheme that helps, and that's going to be pseudocode. Okay, so I think we're going to take the problem at hand. We're going to pseudocode it, and then we're going to implement the pseudocode, and that's probably what I would recommend for you when you go to tackle exercise 11. So here, the example that I'm doing is a classic that it's been in programming courses for years, but I've kind of cleaned it up to be more au courant. Okay, the problem is called Dating Advisor, and this is a program that is going to tell you whether a particular prospective person is somebody who you should agree to go out on a date with. Okay. And there are two areas of qualification. One is whether their age is close to yours, okay. And the sort of old rule of thumb is if your age is within 7 years of theirs. Now there are all kinds of versions of this, half your age plus 7 years, and all kinds of stuff. But we're going to make it pretty easy here. If your age is within 7 years, then advise yes. Otherwise, advise no. Okay? Regardless of age, advise yes if they have donated $200,000 or more to end world hunger. Okay, this is the part that I've cleaned up because the version that I was taught had to do with what their annual income was. And I think that's probably bad advice. So probably somebody who is this philanthropic is worth maybe a meeting over a cup of coffee, if nothing else. Okay, so let's come up with some pseudocode. Okay, now let's look at this. Could we do this with well, we could do it with if else if, but let's try this. So let's say you always have to decide which one you're going to do first. Okay? And the one that's pretty simple is the one we say second, whether they donated more to end world hunger. So let's say this. Let's just be typing this in. Let's say prompt for age. Okay. Prompt for amount donated to, and we're going to call it End World Hunger, EWH. Okay. Okay. And then we can say if amount donated. Okay. Let's get rid of the EWH here. Just say if amount donated is greater than or equal to 200,000. Now, how are we going to say yes? Well, a really easy way to do that in the Python language is to have a Boolean where it's going to get either true or false, right? So let's say if they meet that criteria, which is only 20,000, I think. If amount is greater than 20,000, then what do we want to do? Then let's say the term is accept. Whether we're going to accept the invitation. Let's give it true. Okay. Else. Okay, and I'm not putting in the colons and all that kind of stuff because it looks like I'm trying to have something that looks not completely Python-like. Okay, so then we get into the other logic. Okay, so the other logic, I originally thought it was an if-else if, but this is another if-else. So, sorry. So, the other thing we need to know, your age and their age, right? So their age, okay. We need to prompt for your age. We need to prompt for their age, right? Prompt for your age. Okay. And probably somewhere up here, we need to calculate the age difference. Okay. And probably to do this well, we wanted some kind of absolute value. Absolute value of the age difference. Okay? Because when we go to test that, we're going to want to know what works there. Okay, so that's pretty good pseudocode so far. So down here, if off of this else, then I've got two situations. I've got one where the difference is 7 or fewer years, and I've got the other one where it's greater than 7 years. Okay, so how are we going to do this? Well, we can say if age difference less than or equal to 7, right? Well, then accept equal true. Okay. And then we can say else except equal false. Okay. So let's just look at the paths through here. Does except always get a value? Well, if the first if is true, it gets the value true. If it's false, then we go to the else. And the else has two situations. If that nested if is true, then we get the value true. Else, we get the value false. So pretty much we've got it. We've got it all along, and then so that's the end of all that ifing. Okay. That's the end of all that ifing. So then we can say print answer. Okay. Okay. Good. Now, what do we have here? Well, we have a chance. We can think of this in two different ways. We can think of this as one decision or another decision, or we can think of this as three cases. Okay, we could actually think of this as an elif and then an else. Okay, that would work fine. Okay, so we can implement it either way. So it can either be an if, elif, else, or it can be an if else with a nested if else. So a lot of ways to do it. I kind of like this one, right? So I'm going to do this one. So let's take all this code that we have here, all this pseudocode, and let's create yet some more comments. All right. So we're going to toggle them into a comment. Okay. So let's come down here and get started. Okay. So we need a main. Okay. So we need to define the function main. Okay. For right now, let's make it empty. So put in that classic path. And you'll remember that we were doing that thing where we were checking to see if we had been called as a main script. And we had that from before. So I'm not kidding you. If I can copy it, I'll copy it. So I've got that. Okay. So that looks good. And we're not getting an error here because we have an instruction in our main. But let's just print a title. Let's print dating advisor. Okay. And then let's print another line to separate it from the prompts. Okay, how's that look? All right, I think we're ready for a test. So let's give it a test. Here, when I would have to scroll way up to get to the play button, here's where I really like to right click and pick a play from the drop down. So let's see what we got. Well, we got dating advisor. It looks like we got a blank line in here. That's good. All right, so let's close this so we get a little more real estate. Prompt for your age, prompt for their age, calculate the absolute difference in the age. Okay. Let's give that a try. So let's do the prompt. So what kind of a number do we want to get back for these ages? I'm going to say I want to get an integer back. So I'm going to set it up so the program's going to fail if we don't get integer ages. And I'm going to be nice enough to prompt the user to give us an integer age. Okay, so let's call it your age equals gets a sign, int. Okay, and then what do we want? How do we want to prompt? Well, with input, and then please enter your age as an integer. Extra space on the end. Okay. All right. And then you might want to say, I like to clone that. So let's call it their age. Please enter, let's just say their age as an integer. I mean, we could be more verbose, but I don't want to right now. Okay. And then let's just print them. Print your age, comma, their age. See how it goes. And let's give it a run. Okay. So please enter your age as an integer, 17. Please enter their age as an integer, 24. 17 and 24. Okay, that's good. All right. So what's the next thing that we need to do in our pseudocode? Well, we need to figure out what the absolute value of the age difference is. We want the absolute value because it doesn't really matter who's older. We just want the number of years as a positive integer. So let's do that. So let's calculate age difference as the absolute value of your age. Sorry, your age minus their age. Okay, and let's print age difference. Age difference. That'll be our test for now, right? Okay. Let's give it a run. Give it a run down here. Dating advisor. So let's say that my age is 24. Their age is 17. And we get a 7. Now you might ask, should people really go on dates when one person is 24 and the other is 17? And I'm going to say that that's really not within the scope of the course. Again, we're just having a cup of coffee, right? All right. So that seems to work just fine. All right. So then let's go back to our pseudocode, okay? So we still need to get the amount that they donated to end world hunger. Okay, well, this should be pretty easy again. And again, do we really care about cents? Do we just want dollars? I'm going to say we just want dollars. Okay. So let's not be lazy. So let's, what were we calling it up in the pseudocode? Was it donated amount? Amount donated. Okay. Amount donated equals, and again, we want an integer. Well, do we really care? It's not really going to matter, I think. So, yeah, so let's not. If we don't really need an integer, let's do an eval. That'll allow either an integer or a float value to come in. And input again. And please enter amount they have donated to end world hunger. colon, space. Okay, now that's gone off the right side, but that's okay. We know what's out there. Okay. So we probably want to print that just to make sure that we're getting it in okay. So print amount donated. Pretty good. All right, so let's run a test again. Test early, test often. Okay, age is an integer. I'm 1, they're 1. Difference is 0. How much have they entered in world hunger? Let's say that they gave $50. Okay, so we've got 50. We're okay. So now that we've gotten all that logic in there, I think that looks good, right? Let's well, we don't, a lot of times when we talk about logic, we're talking about decision logic. So we've got we've done all of our data collection. And we've also kind of pre-calculated the age difference so that when we get into the decision logic, we aren't going to have to be doing fancy calculations in the decision logic. And that's a pretty good and common trick. All right. So let's give ourselves some room here and see where we are. So I'm thinking that this code in here looks a lot like Python. So I'm just going to copy my pseudocode down, and I'm going to turn the comments off. Toggle the comments off, and I'm going to highlight this, and you can typically tab over a block of text with the tab, so I tabbed it over, and looks pretty close except that we have no colons at the end of these things. So on the first if, I need a colon to turn it into proper Python. Except true, well, true as a literal Boolean keyword in Python begins with a capital. Okay. Else, that needs a colon. Age difference less than or equals 7, that's going to need a colon. Okay. Our true, it's going to need to be turned into a capital true. Our else is going to need a colon. And our false is going to need a capital F. Okay, how does that look? That looks pretty good to me. Alrighty. Now I'm down to printing the answer. Okay, and it's going to be easier to test this if I'm printing the answer. So let's do that. Okay, so let's say we want to print the answer. It's going to go on the next line, and it's going to be out at the level with the if and the else. Okay, so let's print. Let's have an if. So we can say if true. No. Sorry. If except equal true. It's kind of a long way to say that, but we'll leave it there. Well then, what do? Well, we're going to print one message. Else, we're going to print the other message. How does that look? Well, it looks good. We don't have a colon on our else. Let's get that fixed. All right. So what do we want to print? Well, we want some character string. yes, schedule the date. Okay. And then the second one, oh, sorry. I don't know how I got that wrong, but I did. So the second one would be no. Oh, and again, when we have a yes, that's a full sentence. So let's make that a capital S. And let's say no, that's a full sentence. We advise against it. How's that? Well, it looks pretty good to me. And we have a couple of blanks. We should have 2 blanks, and then we have our call to main, our conditional call to main, all the same, but our call to main. Okay, that looks good. All right, looks good to me. Let's look at all the operational code now. Okay, prompting for your age, their age, calculating the absolute value of the difference. We don't need to print the age difference anymore. That was part of our testing. Let's get rid of that. We calculate the amount donated. We prove we got that in. That was part of testing too. Let's get that testing code out of there. And now we get into the decision logic. Okay. And we'll give this a try. So let's just give this a try. Fine. So let's run. So enter your age as an integer. Okay, so let's say 20, and their age is 24. Well, the amount they donated to end world hunger, let's say nothing. Yes, schedule the date. Okay, sorry, hit my headset there. Let's run it again. So let's say 20 and 24 again. No, not 20 and 24. We need to get into the other conditions. So let's say there's a difference of 10 years, 20 and 30. Okay, so how much do they donate to world hunger? Let's say $100. No, we advise against it. Okay, that looks good. Okay, so now we have to test the other conditions, because there really are 3 conditions in which it's there are 3 there are 2 situations in which it's true and 1 in which it's false. So let's do it again where it's true. So let's run it again. And let's make this a little bigger. Okay. So let's say there's a bigger age difference again, 20 and 30. So that's over 7 years. But let's say that they have donated exactly $200,000 to world hunger. 200,000. Yes, schedule the date. So that looks like it's working. One thing I don't like is just the way we're testing it. Okay, we're testing it in a very user-intensive way. Okay, again, we have to remember all the test cases. Okay, not only do we have to think about once, we have to remember them. 2, we have to type the input in appropriately, and then 3, we have to inspect the output and remember what the expected answer is. So what I'm going to do is I'm going to factor this one, just like I factored the last one. I'm going to refactor it. I'm going to put the code that does the decision on whether to date or not. I'm going to put that into a function. I'm going to factor it into its own method or function. And then I'm going to have, instead of having this being a conversational test, I'm going to have this be a more systematic test where the code in the main is just going to be calling the function with the decision logic in it, one test case at a time. All right, so let's close the bottom part here. And the first thing that we need to do is we need to segregate this decision code. And I'm going to say that this is the code that does the decision making. The code before, the code through like 32 through 35, that gets the inputs ready, right? And then we'll see where we are. Now, I'm going to say, maybe I need to change this a bit. Okay. I thought it was a nice idea to calculate the difference in the age up here while I was thinking about it. But shouldn't calculating the difference in the age be part of the algorithm that we're trying to encapsulate? We're trying to put it into a function? Well, I'll say yeah. So really, I want to make sure that gets into the method as well. So this age difference, I'm going to cut that out of here and put it down here. Okay? Well, sorry. Age difference is going to go down here. And I'm going to put a blank line in here. And I'm going to put this back here. So now I'm going to say, okay, now this is a little bit better. I'm getting the 3 inputs, and now I'm doing the work, and the first thing that I thought of as kind of pre-work before is still part of the decision logic, because we are pre-calculating something that we could, at least in theory, have calculated down here. Okay? All right, so let's just run one test case to make sure that we haven't broken it. So run a test case. What do we have? Let's say we've got 11 and 18 and 0 contributions, and yeah, schedule the date. So that looks good. All right, so close this. So now let's try to extract the method or function. So I'm saying that what we wanted to extract is this, because what do we need? What are the appropriate inputs to the decision? Well, your age, their age, and the amount donated. And then we'll do all the work down in the function. So if we highlight this just the right way, it turns out that the wizard that does the method extraction will set up everything for us. So let's go to Refactor, Extract, Method. And we need a method name. So let's think of what that should be. Determine dating recommendation. Okay, and you might say, well, Kevin, that's a little long. I might say, well, you know, these are only characters. Typing's cheap, right? Okay, and then so what are we going to get here? This is interesting too. Do we really want a code that does the recommending to do printing? Or do we want it to send back an answer, yes or no? Now, it's going to be a more general piece of code if it passes back an answer, because there's a lot of times, and I mentioned this before, that we're going to use our code in a context where we're not printing on the console. So having these functions that print their answer on the console instead of returning the value, they're too specific. They're not general enough. Okay, so let's say maybe printing the answer is not part of what we want to encapsulate into a function either. So it's maybe just this stuff in the middle. Let's try that. So this is going to give me what I was intending, okay? So I'm now going to extract method, okay? And what are we going to get? Well, the method name, but we had one before, determine dating recommendation, okay? And what are their input parameters? The amount donated, their age, your age, okay? And what are the output variables? What are you going to return? Well, this accept, this Boolean decision. So let's say, yeah, okay, refactor it. And it refactors it for us, okay? So I like this, all right? I'm going to change a couple of things, but let's just see up here. Let's just take the code that we have and tighten it up a bit. Okay. My, this is not working like I wanted to. Ah, there it is. Okay, so we've got it. So again, we should be able to run this. Refactoring really says that you're trying to not change the functionality at all. You're just trying to make it a more maintainable, easily understood program that's less likely to have errors in it because it's factored into a more maintainable state. Okay? And I think that extracting this into a method was just the thing that we needed. Okay, so let's give it a run. Run. And again, we're just going to test easy use case. 14, 0. Yes, schedule the date. Okay, well, I don't think we've broken it, so that's good. All right. So we could stop here, except that I think that this is a pretty inefficient way to test code. Okay. Now, the question is, do you want to be creating here a little application? Or do you want to be creating some code that does the testing, and do you want to test that efficiently? In this case, I'm going to say that it's the latter. Okay, so because I'm kind of building to a future where we're building reusable code, I guess I would call it. So I'm going to do with this the same way I did it before. Now, is this a refactoring? No, this is sort of a redesign of the testing scheme. If it were just refactoring, when I got done and I ran it, it would do exactly the same thing. Well, that's not true here. It's going to do something different. Okay? So how are we going to do this? Well, let's look at this. So determine dating recommendation. This line seems to be what gets it done. Okay, so let's get rid of all those user-friendly funny things up there. Okay, and oh, sorry, we don't want to prompt for anything at all because it's going to be our assumptions are just going to be in our test code. Okay, and we're going to do this. So if we do a call to determine dating recommendation with the amount donated, their age, and your age, okay, well then that's going to work real well. Okay, now one of the things that I'm seeing here that I don't like is the order that these things are in, because the natural order for me is your age, their age, amount donated. So let's change the order down here. You just go down to the formal parameter list. Okay, and let's put your age first. And a comma. Let's put their age second, and amount donated third, and let's get rid of the extra spaces and comma. Okay, so now we're expecting to get them in a more natural order, but now we have to change this. Okay, this is going to have to go in the right order up here. Your age, their age, amount donated. So we're actually going to type these in as literals. Okay, so the first one, let's have this be a case where we're the same age. So let's say 17, 0. Okay. Okay, and what are we expecting to get back? Well, 17, 0, we're expecting to get a true back. Okay, so if we get accept off of here, if we have an expression that says we're going to call determined dating exception 17, 0, and we're going to expect it to get back a value of true. Well, can't capitalize them all. True. Okay. Well, that's a true statement. Okay. So what we do is we have the call with the parameters that are a test case, and then we compare that to the value that we are returning. So we're expecting to get back a true. Now this expression is something that you can print. You just put a paren there and a paren here and put a print in front of it. And that's our first test case. So what does it say? Well, I want to call determine dating recommendation, my age 17, your age 17, their age 17, contribution amount 0, and we're expecting to get back a yes, true. Okay? Now, if this is a test case that passes our test, we're going to print true. Well, let's see if we print true. Let's give it a run. Run. And look, it printed true. Okay. Now, so if they're same age and they haven't donated anything, then it prints true. Let's say this. Let's say, what if they're the same age and they've donated a whole lot, like say $250,000? Well, it should not be relevant. Okay, so I'm going to say if it's $250,000, I'm going to still expect it to be true. Okay, let's see. Let's run it. 2 trues. Okay, that's good. Okay. That's another test case. Now let's keep thinking about test cases. Okay, we have them when they're equal. All right. Let's try to test them where my age is less than their age. Your age is less than their age. So let's try this. Let's say if our age is 10 and theirs is 17, it should still pass because there's 7-year difference there. Okay. Let's give that a run. True, true, true. That works. Well, what if it were the other way? What if you were 17 and they were 10? Well, let's look at that. Just swap the order of the two values, 17 and 10. Regardless of how much you or they have contributed, it should still be true. We should still be getting yes. You should accept the invitation to have coffee. Or in this case, 17 and 10, perhaps you might like some kind of soda or pop, depending on where you're coming from. Okay, so that's all looking good. Those are all the passing cases. Now, so we had a passing case where it was under $200,000. A passing case where it's over $200,000. I think we've shown that when the ages are right, that there's not going to be a problem. And then we've gotten to the edge of these age differences. Let's see what happens when we go past the edge. Let's look at the boundary. Let's say if we have a difference of 8 years. Okay, so let's say if we have a difference of 8 years. Uh-oh, didn't get the whole statement there. Triple click, I usually do it. Copy, and come down here and paste. Okay, so let's say we're 18 and they're 10. Okay, this is kind of silly though, and nobody has contributed anything at all. I'm expecting it to come back with no. Okay. Well, if I leave everything the way it is, I'm going to get a failed test because I'm predicting it coming back true and it comes back false. So let's look at this. Let's give it one more run. And look, I got false down at the bottom. Oh yeah, that's right. That's supposed to be bringing back a false answer. So when we do that and we run it again, well, they're all true. That's good. Okay, so let's say that we are out of whack the other way. Let's say we are at least 8 years the other way. Well, let's do that. Okay, so you're 10, they're 18. Okay, they haven't contributed anything at all. Okay, and we're going to expect that to fail as well. And it did. So we got back a false answer, but we have a passed test. Every tested pass is giving us a true. Okay, so let's see if we're just under the contribution amount here. Okay, so let's take the first of these and let's say, well, what if we almost contributed enough? Okay, so what would be almost enough? Well, $199,999 could be as close as we can get without making it. Let's say this, $199,999.99. Remember, we didn't say that it was going to be an integer. So we're expecting this to be just shy. Let's see what happens. Okay, we're expecting it to be false. Not enough to tip it in. Okay, let's run it. Yeah, right about that. Okay, do I need to test the other combination? Well, I guess I could. If I want to be kind of compulsive about this, we know that the logic is not susceptible to do this, but we'll do it anyway. We'll say 18 and 10 and 9, just a penny under the limit. Okay. All right, that's good. So we're expecting that one to fail too. Let's see what happens. Yep. That test case works. Okay, and then let's just go right over the limit. Okay. So let's say we've got 18 and 10, and we have just $200,000. $200,000 and 00 cents. Does that work? We're expecting that to come back with a yes. So make that equal to true. All right, let's see what we've got. Run. True, 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 true. So what we have here is we have 1, 2, 3, 4, 5, 6, 7, 8, 9 test cases that pretty exhaustively test the code, and we've set them up in a situation where all we really have to do is to run the main, right, and check that all of the prints are true. Now again, is this the most sophisticated testing scheme? No, it's kind of a homegrown version of a sophisticated testing platform that we'll see before the end of the course. But this is the kind of testing that is tested. Okay? We've identified all the test cases we consider to be relevant with proper attention to the boundary cases. Okay, and we have predicted the results, okay, and then we have set this up so we can see whether each of the test cases it gives the results that we anticipate, and we have an easy way to check the output and just see, yep, we got all our test cases passed. Okay. So it's a bit homegrown, but it's really going to do the job. So the only thing I've got left to do is to clean this up to make it ready for prime time. I'm going to get rid of my pseudocode because nobody's going to maintain that. Okay. And the rest of the stuff looks good. Maybe too many blank lines in the end. All right. And then let's run a test one more time. And those are all coming up true. That's still, haven't broken anything. And the only other thing I'm going to do is I'm going to go up and click on code, inspect code, and see if it has any complaints about my current file. So it doesn't like my equal true. So interesting. Very, very interesting. It rather would see us say if condition is false. And you know what? I'm going to say that for the test code, I can take this. I kind of like the way this reads, okay? And the way you can change the values. So even though it doesn't like our style, according to the PEP8 style, I'm going to take a pass on that, okay? I mean, this is good Python. Perhaps it's a little too literal. But we're going to learn a little bit more about Booleans and such in the next chapter, and maybe we'll improve our syntax on this when we get there. Okay, and this is a parallel to what we did in the last example where we were testing an if-elif situation. Oh, and another thing that I've got to change, I just want to say, is I do have comments that are wrong because I never really used an elif. Okay? One could say that logically, oh, sorry, let's undo that change. One could say that logically this else and then an if after it is an elif, but it's not a literal elif. So we're going to have to say using nested if else. Okay? And you just pick the tool that you need to do the job. I saw it this way. We could have used an elif if we wanted to, but I decided to not. Okay, so this is a nested if. A nested if else. And again, I've changed the code. Let me give it one more test. Oh, we're all coming up true. I'm happy with that. I'm going to say bye. So that's it for the tutorials for this chapter. I'll see you next time. Bye-bye.